In this video, we're going to be looking at term-to-term rules for sequences. First of all, what is a sequence? Well, a sequence is an ordered collection of objects. Now, most frequently, these objects in a sequence are numbers, but they don't have to be numbers, they could be algebraic expressions, as we'll see in the future. But for now, let's take a simple example of a sequence. Let's say I've got 3, 10, 3, 10, 3, 10. This is a sequence, and there's a fairly obvious pattern here. It just goes from 3 to 10 to 3 to 10 to 3 to 10. Notice a sequence doesn't have to keep increasing or keep decreasing. You'll see here that this is going up and down and up and down and up and down between 3 and 10. Like I said, the order matters. So if I had this sequence here, 10, 3, 10, 3, 10, 3, and so on, these are not the same sequence. They're different sequences, even though they seem to consist of the same objects. The point is, the objects are now in a different order in this second sequence compared to the first one. So, we know what sequences are. We need another bit of vocabulary before we get started on these examples. The vocabulary we need is the word term. It's the word we use to refer to objects in the sequence. So let's take the original sequence, 3, 10, 3, 10, 3, 10, and so on. We would say the first term is 3 because it comes first in this sequence. The second term is 10, the third term is 3. The fourth term is 10, the fifth term is 3. The sixth term is 10, and so on. Right, let's have a look at the examples. We have some descriptions of some sequences. In sequence A, we're told the first term is 7 and the term-to-term rule is add 3. And then we've got similar descriptions for the remaining sequences. Finally, we've got a discussion point at the end. But first, let's get down to this. We need to list the first 5 terms of each sequence. Well, let's start with A. We're already given the first term, so I know that the sequence starts with a 7. Now, the term-to-term rule is add 3. What this means is that to get from one term to the next term in the sequence, this is what I have to do. In this case, add 3. So if the first term is 7, then the second term will be 7 plus 3. I add 3 to the first term to get the second term. To get the third term in the sequence, I need to apply the term-to-term rule to the second term in the sequence. So I need to add 3 onto 10. That gives me 13. Carrying on, I get 16 and 19. Now, this sequence will continue forever, but I only had to write down the first 5 terms, so I'm going to stop here. Pause the video and see if you can list out the first 5 terms of the next 3 sequences. Here's what you should have got for B. The first term is 10. The term-to-term rule is subtract 2. So to get each subsequent term, I subtract 2 from the previous one. 10 minus 2 is 8. So that's the second term. 8 minus 2 is 6. 6 minus 2 is 4. And if I keep subtracting 2, I end up getting 2, 0, negative 2, negative 4, and so on. But I only need to write as far as this because I was listing the first 5 only. In C, we start off with 3. That's the first term in the sequence. The term-to-term rule is multiply by 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And those are the first 5 terms of this sequence. In D, we start with negative 14. Adding 6, we get negative 8. Adding 6 again, we get negative 2. Adding 6 again, we get positive 4. And adding 6 again, we get 10. Those are the first 5 terms of this sequence. Moving on to this discussion point. Each of these descriptions contained 2 bits of information. We were told something about a particular term. In all of these cases, we were told the first term, but we also had a second bit of information. We had the term-to-term rule in each sequence. Do we need those 2 bits of information? Or could we have worked out these sequences from just 1 bit of information? Well, the answer is we need 2 bits of information. Just one of those bits of information on its own would not have been enough. For example, in sequence A, if we were told that the first term was 7, but we didn't know the term-to-term rule, of course, we could have identified the first term correctly, but we would have no idea what to put next. How would we know whether we were adding 3, or maybe subtracting 17, or multiplying by 10, or dividing by 5? We'd have no idea. So having the first term on its own isn't good enough. What if we had the term-to-term rule on its own? Well, great, that is helpful, but how would we know where to even begin? What would the first term of this sequence even be? We would have no idea. For example, we might just guess and put down a 5. If we add 3 each time, we would get 8, 11, 14, 17, and so on, which is a sequence that follows this term-to-term rule, but it's not the same sequence as this one in blue. So just having the term-to-term rule on its own is not enough to fully describe the actual sequence. We need the term-to-term rule and we need information about a particular term. Now that could be the first term or it could be any other term, but we need the 2 bits of information. And that's the key idea from this video.